welcome to this first session of Everyday Cryptography. I'm the room host. Since we're running 2 minutes late, I'll just get to it and introduce Hans, who's going to talk to us about setting up some open source and secure private file and data sharing.
Yes, good morning. Thank you for turning up so early on a Saturday morning. Good to be here. It's my first time in Gothenburg, and I already feel that I need another excuse to come back here, so awesome city. Who am I? I've got my own company. I'm based in the Netherlands, mostly working on open source, open standards, software security, audits and stuff like that. I'm a partner of Kolab Systems AG from Switzerland, and basically what I do is whatever I like and with which I can find a customer. So why would you want to host your own groupware environment? Because it's a lot of work and you have all these excellent commercial alternatives. Well, the problem with most of the commercial alternatives, as you're probably aware, are that you don't actually get to be the customer. You don't have a decisive vote in whatever the platform will be doing with your data, because actually the data you're entrusting to the platform is the currency with which you pay the platform. Also, in Europe we now have the very interesting situation that Safe Harbor has been axed thanks to the Schrems case, which basically means that if you host a company and in any way use personal data of your customers, you have to take additional measures before you are allowed to exchange that data with American-based companies. And most of, especially the SME companies that I work with, but also governments and large enterprises, well, they actually don't want that. They want to have a clear legislative framework in which they can entrust their data, and at the moment, well, the legislative framework has become as cloudy as the cloud services themselves. So that's another reason why you want to entrust your own data only to yourself or to a party that you can actually control. Because contrary to popular belief, law actually beats technology. It doesn't matter how well encrypted your files are, if a country or entity has the power by law to request your data, and if you don't give them your data, well, it's very simple. They just throw you in jail or start waterboarding you, and chances are at some point that you will give them the password. So you have to think about where to store your data, because it goes the other way around as well. Actually, Microsoft, I said the M word, yes, in the past couple of years has made a very big promotion campaign of being one of the more trustworthy and privacy-aware cloud providers, and actually claiming that because they were based in Ireland and they were under European law and Safe Harbor, that they didn't have to provide American entities access to their data. Well, we all know because of the Snowden revelations and now also because of the Schrems case that that's utter bullshit. So basically, law beats technology every day. And like I said, Safe Harbor is dead. So make sure your data is in a place which is as much as possible within the same legislative framework as you are, because that makes it a lot easier to actually do business transactions with your customers, or simply be able to go to court if someone violates your own privacy. Because as a non-American citizen, you have no rights whatsoever in the American judicial system when it comes to your data protection. So far, the fear-mongering. If you want to do it yourself, and there's a lot of other benefits of hosting it yourself, not only because of big evil corporations stealing your data. It's also because it gives you a very warm and fuzzy feeling having your own data. And it also is very cost effective, because if you want to store terabytes and terabytes of data, it's usually cheaper if you do it yourself. But make sure you know what you're doing, because in recent years we've seen all kinds of web-based file cloudy applications starting to pop up here and there, and usually these applications were built in normal web frameworks like PHP or Node.js or something like that. And well, perhaps the platforms themselves by now have become more and more secure. A couple of years ago they were absolutely not secure, but nowadays I believe they've made some efforts into it. But you still have to know how to configure your own server. You still have to know the common pitfalls of how to configure SA Linux or AppArmor or stuff like that. So make sure before you start deploying some web application, yum install OwnCloud, yum install Seafile or anything else, just make sure you know what that thing is doing. And the same thing goes for Kolab as well, of course. It's a pretty complex application. It consists of multiple components. It has a file server, an email server, a web server, web application. You should at least understand what you're doing, or else you should hire somebody who does understand. And what I see in the Netherlands, and that's fun development I think, I see corporations or collaborations between small groups of people who actually together start paying somebody, a sysadmin, who keeps up a VPS in his spare time, to simply host it right. And that's fun, because then you can give somebody you trust some money to simply make sure that your server is configured right, and whilst at the same time have the benefits of hosting it yourself. So what's Kolab? At some point in the end of the 1990s, the German Bundesamt für Sicherheit und Informationstechnik decided that for some reason they didn't exactly trust the regular commercial Groupware vendors, and they were using Lotus Notes at the time. There's a known incident in 2002, right before they switched to Kolab, in which they were compromised on their Lotus Notes environment. So the German BSI, they do take their data seriously, and they decided simply, well, there is no alternative at the moment, let's build our own. And they built Kolab, where they started calling it Groupware. But nowadays it's called, thank God, Kolab. And it has a couple of, it has multi-platform clients. It has a web front end called Roundcube, which incidentally is the world's most popular open source web client. We have over 500,000 confirmed installations of the damn thing, which is awesome. We have KDE Contact, which natively integrates with the Kolab metadata and agenda and file sharing and everything. But you can also use Mozilla Thunderbird or even Microsoft Outlook or something else. That's also possible, because we actually have a fully open source active sync component, which is quite interesting because it actually works on Android and even on Windows Mobile. So the best part is also that security has been built into the platform from the start, and the BSI still uses it, and it not only uses it, it keeps developing on it. And obviously if you ask the BSI whether they use Kolab, they will confirm nor deny it, but in any way, they do. They even posted a white paper on how to install it securely a couple of years ago, which is interesting. So, Kolab consists of a couple of normal, regular open source projects. You have Apache or Nginx, Postfix, Cyrus, MySQL, and the best part about Kolab, from my point of view, is that it doesn't replace all these components. It's just adding a layer of metadata between those components. Because if you look at other open source Groupware platforms like Sarafa or Zimbra, they pretty much built their own mail server, and they pretty much built their own calendar server. And well, we think that's a bit besides the point, because there already are so many good platforms, and especially Cyrus, on which we build most of our architecture, Cyrus is incredibly scalable. It's very easily secureable, and this is a picture of the Kolab architecture. Basically, we use the IMAP server, so Cyrus, as somewhat of a NoSQL database. Everything is stored in the IMAP server. So also your agenda, appointments, and your contacts, and your files, and your notes, and your to-do items, everything is stored in an IMAP server. And why is that cool? Well, because it's simply flat file system. So you can easily back it up, you can easily restore it, you can easily replicate it over multiple nodes. That's awesome, because most other systems, they have a SQL database with all kinds of metadata and permissions and everything else. We just do that in LDAP and IMAP. You don't even need an SQL database. You only want an SQL database if you want to store your settings in Roundcube, and that's because Roundcube uses MySQL. Kolab itself, it's just a metadata layer between the IMAP server, the LDAP server, and the front end. And we also offer all the data in the system through industry-proven open standards like IMAP or CalDAV or WebDAV or whichever other standard you can come up with. We're also working on a CMIS front end to integrate our document management with Alfresco or other systems. So how do you plan to set up? What do you need to think about? You need, well, obviously, how valuable is your data and how much data are you allowed to lose at some point towards yourself? Because setting up a failover scenario can be quite intensive, it can be quite expensive. Do you really need it, or can you simply sync your data every hour with some other server and simply accept that you will lose some data at some point? These are aspects that you need to think about upfront. Fortunately, most of the server components in the Kolab stack are easily set up to be self-replicating. Cyrus IMAP has the Cyrus Murder technology, which is horizontal replication, and the LDAP server, 389 server, can also easily work with a master and a child, and etc. So, but you need to think about it. Also, when it comes to access to your data, especially also file access and replications, do you want access or do you want to sync? And why is this important? Well, if you host a terabyte of files in your file sharing system, you don't necessarily want to sync that all the time. Because especially if you work in an office with a lot of computers and you have like 100 computers syncing all your data all the time, you'll end up DDoSing yourself. That's a bad idea. So, do you need access or do you need sync? Think about what you want. And everybody who's still coming home, welcome. Same is for email. Do you want to always have offline backups of your email? Mozilla Thunderbird, by default, pulls everything from the server all the time. That's really interesting, but if you have roaming profiles in your network environment, you end up with roaming profiles of several gigabytes big. That might be counterproductive if you log in into a new server. Also, expectation management. If you want to share this with a number of people, talk about this with the people you're sharing it with, or talk about it with your boss. You need to have a picture up front of the demands of what they have on their data, because you as a sysadmin or an enthusiast can have a certain picture. Hey, as long as my data is there and it's backed up every day, I'm happy with it. But maybe your boss or your partner or your friend or co-worker has an entirely different picture. So make sure that you align on this. Also, like I said, decoupling and redundancy. Because Kolab is a platform that consists of multiple components, you have to think about decoupling and redundancy on a component level. You can't, or you should probably not, directly mirror one Kolab server with the other, because, well, that's then you're simply replicating an integrated web of configurations. What you want to do is you want to replicate the components within the stack, like the web server, the database server, the IMAP server, to make sure that the components by themselves have failover abilities. So you can do that two ways. You can do it indeed on a component level, or you can use even lower level, block level synchronization. And this is something that a lot of people actually tend to forget. But if you want to synchronize a file system or something, it's much easier usually to use block level synchronization like DRDB instead of actual file synchronization, because if you use block level synchronization, the only things that are actually synced are the blocks which are actually changed. But if you use file synchronization and you have a 1 GB file, if 1 byte of that 1 GB file is changed, usually you end up syncing the whole thing. So think about that as well. And think about two terms as well, HA or HR, which is high availability or high recoverability. And the basic question that you need to ask yourself is how many hours of business can you survive without having access to your data? High availability usually means you have failover systems, and if something goes poof, then something will switch automatically to the other server. And high recoverability means that, oh shit, my server is down, it will now take me an hour to get it up again. Choose what's acceptable for you, because high availability is much more expensive usually than high recoverability. So we've already gone over this a little bit with redundancy and application level. These are the layers that you need to think about to implement redundancy towards MariaDB as clustering, although that's a bit of a masochistic thing to set up. Cyrus has Cyrus Murder, which simply is horizontal scalability built into the Cyrus platform. It's amazing. And because in Kolab everything is in your IMAP server, everything is automatically replicated over multiple nodes. So this is actually the problem that I usually start with when setting up a redundant Kolab environment. LDAP replication, also quite easy to do. SMTP. Again, you have to ask yourself two questions. What do I want to prevent? Do I want to prevent mail loss? Or do I want to ensure mail availability at all times? Because if I only want to prevent mail loss when I'm performing updates on my platform, then just put another SMTP server as a failover, which buffers all your email in a queue, and as soon as your main SMTP server comes online, delivers all the mail again. Or do you want full-time availability? Then you have to have two SMTP front ends syncing back to the Cyrus backend all the time. Again, this is much easier to set up because this is pretty much what Postfix does by default. If it can't deliver anything through its component chain, it will simply buffer it until the component that it needs to be delivered to wakes up again and start accepting stuff. So the web server, well, that's also quite easy to replicate because the web server itself doesn't host any data. Contrary to a lot of other open source file syncing applications, the web server in Kolab is an entirely dumb thing. It has no application logic whatsoever. It's just authentication and passing through the files and the aspects in the system, so it doesn't store anything itself. And that's a very good thing for another reason, because most other file syncing tools, they keep some kind of index in a database. So you have an index of your files in a database, and you have a file system. So these are two realities that need to be in sync with each other, and that usually goes wrong at some point. Especially because with most of these systems, you can actually access the files in the file system without the system knowing. And then you simply get a corrupted state between your index in your database and your index in your file system. And from a security point of view, it's also much safer to have everything in your IMAP server. And why is that? Well, IMAP has this lovely thing called ACLs, Access Control List, built in the platform. So the user that logs onto the IMAP server only has access to to those things that the ACL of the file system server, the IMAP server itself, will allow it to. And that's built in the platform. So a lot of other file syncing tools, they have some kind of PHP ACL library, which simply is, well, the web application doing something with authentication, which doesn't reflect the file system itself. The file system itself is still open to the web server user all in all. So data syncing, we've gone on into that a little bit. Basically, you have block level sync, DRDB, file level sync like RasterFS, or if you really want to go crazy, use Ceph, and then you have a multi-continent based cloud platform with some quantum mechanics inside it, which is awesome. Pick your tools wisely. It all depends on the amount of data you want to sync, and it all depends on the amount of assurance that you need to have. And especially if you're setting up stuff at a VPS provider, make sure that you always have a backup of your data at another VPS provider, because you wouldn't be the first one to have an incident in the data center of the VPS provider and your data would go boot. So it's always a good idea to spread risks, and the beauty about cloud is, well, the Free Software Foundation Europe says it like this: there is no cloud, there's just other people's computers, which is the truth. And think about the cloud as just being another computer in your own infrastructure, which means you have to provide failover. Even if you're relying on Amazon, or even if you're relying on Google, which I wouldn't do, but still you can, something can go wrong. 3 years ago, Gmail had a little oops moment in which they deleted 200,000 mailboxes. That sucked. Although it cleans up nicely. But what about a simple snapshot? Yeah, sure. I mean, that works as well. If you host this on your own virtual platform, or you have VPS or something, making a daily snapshot can be perfectly acceptable if you allow for data to be lost from the time that you've made the snapshot until the time that you discover you have an issue. But again, think about what you do, and that's the basic mantra of this whole talk is think, plan, do, check, act. Don't plan, do, check, and run. Server-side encryption. I love server-side encryption because it's being marketed as a privacy solution, which is bullshit, because the sysadmin still always has access to your data, and since it's encrypted usually on the server, and which is a shared server spread over multiple people, how is that private? The only thing that's private about it is that if you have an incident where your file system, your shared file system from your VPS provider is compromised, it's not that easy to access your data from below. So, but in general, it's not a privacy matter. And why not? Well, server-side encryption requires the keys, the encryption keys, to be present on the same infrastructure part as your data is. And everybody who knows anything about encryption knows that if you have the keys and the data in the same place, you have access to the data. But it can help to at least prevent some common attacks. And also if you run your own hardware or your own laptop, I run my own laptop with an encrypted home partition as well, because, well, if at some point I might lose my laptop, then I don't want somebody to access it too easily. And the same goes for a VPS. If the server is powered down, nobody, or at least without the key, has access to your data. But if you do want privacy, and especially if you do want transport and communication security, so exchanging confidential information, you should use something like PGP or S-MIME, which simply is a plugin you install in your email client, like Enigmail for Thunderbird, or KPGP for Contacts, or GPG for Win for Outlook, or whichever one. You have Mailverloop for webmail, which is also quite nice. So there's a lot of possibilities to encrypt your mail end-to-end, and also on mobile. This is also quite easily done. You have open keychain on Android, and I'm sure that even Apple has something. The only thing that you need to think about regarding the end-to-end encrypted part is the public key exchange. And of course you have to make use of either a public key server or you embed the keys in the messages you send, because else the other party will not be able to communicate back with you. That might be counterproductive. But end-to-end encryption, if we go into the public PR kind of thing, server-side encryption has nothing to do with privacy. End-to-end encryption has everything to do with privacy. And one other thing, put your configuration into Git. Why is that a smart idea? Well, you can track changes. Also, you can see if somebody, your colleague or your coworker, has had an oopsie with your configuration. You can simply see what he's done. You can refer an issue, and it's much easier if you update the packages on your system and RPM decides, or apps decides to change config files. You can easily check what went on. This is very easy to do. It's just git init on your attachment directory and your run free, and commit changes so that you can revert, etc. But I assume that you know Git a little bit. So, back to reality, and I've now spent about half an hour talking about all the things that you need to think about when setting up your own Groupware server. I actually could go on talking about this for a couple of days, or as soon as my vocal cords start breaking down. But there's a lot of considerations when it comes to hosting your own data. And especially hosting your own data in a way that is not equal to losing your own data at some point, because unfortunately that's what happens quite a lot. So, let's set up the damn thing. If you have anything, a server ready, VPS or a VirtualBox image, it's quite easy. Just download an ISO and deploy it. We have, I'm using Ubuntu for the later slides. Why Ubuntu? Well, reasons. You can also use CentOS or OpenSUSE or whatever. But you can also, and this is something really nice, we've had this for I think a month now. Univention is an open source Debian-based SME server, and you can pull an image from the Univention App Store with Kolab Enterprise, run it on your own VPS, run it on your own virtual machine, configure the damn thing, and you have a working environment which is actually configured with some level of sanity. You still have to configure backups and stuff yourself, but the server itself is configured quite decently with some nice security assumptions in there as well. And because it is Kolab Enterprise, if you want support, then you have to pay at least something for it. But that's the enormous amount of 15 euros per user per year. So that should be doable. If you don't want to pay or something, you can also use the community edition, which you can download from kolab.org. And if we make it through the time, then I'll simply go through the slides on how to install that as well. And of course, the slides will also be published after the presentation, so that you can simply copy and paste all the commands and see where I made a mistake. If you download the Univention app and install it, it will show an install screen. You simply go through the installation routine as would you normally do with any kind of other server. Configure a domain. It helps if the domain that you're configuring is already up and running, because else you won't be able to test it, of course. And also think about proxy services, or if you're behind a firewall or anything, because there are some components of the Kolab stack and the Univention stack which deploy web services that have to reach back towards themselves. And that means the web, for instance, the web client from Kolab, runs you, it has access to your files, but that access is done through WebDAV. WebDAV being a web service format, it should be able to access its own file server. And if you're behind a proxy server or a NAT, that opens up a whole myriad of annoying issues. So think about the configuration. I'm just saying that normally you wouldn't have an issue with this, but if you run this in an enterprise, you will. Set up the domain, choose if the Univention server should be its own user container, or if it should integrate to an existing Active Directory or other LDAP domain, because you can very easily integrate this into your own identity management environment. Just hook it in the LDAP server, replicate it, and you're done. You can use also something like Apache Syncode if that's what you want, but it's all LDAP based. Enter account information, that host. Enter host settings, confirm anything, it will install, and you're done. It will restart, and it will open up a simple splash page with the address to the server that's hosting your Univention instance. Now there's one thing you need to think about. You need to activate your Univention instance. They will email you a license file. You can get it through email, upload it, and you're done. Univention is also fully open source, by the way. The Univention components are also hosted in their own Git laboratories. So the license is only for support. And if you look at the privacy terms of service, both Kolab and Univention, and I really invite you to, because it's only one A4 paper instead of the Magna Carta. It's actually readable. They won't sell your data. Actually, Kolab can't even sell your data, because being based in Switzerland, if they sell your data without you knowing it, they will go to jail. And I pretty much am certain that they don't want to meet Bubba. So, UCS has a very nice web interface. You can also install all kinds of other apps on it. You can manage users, devices, domain, system, etc. It's if you use OpenSUSE or something, this is a bit like Rust. It's very user friendly. It's very easy. So Kolab is just another app on the Univention platform. At least that's what they think. You can use the normal user management interface of Univention for the Kolab users. Just add another user, provide credentials, enter information, and you can also add information about file system quota or delegations and email groups, sharing and everything. You can all edit through this interface. You can also edit through the Kolab CLI commands. If you're a bit not into graphical interfaces, you can use Bash, so rest assured. And then you open up RoundCube, and that looks like this. And you can add, like you see here, the files in Kolab are just another folder in your IMAP server. It's just another folder with a different content type. And because of that, you can easily use the same access control lists you use for your mail and your groupware environment, like agenda and everything. You can use the same HCLs for your files. So if you work in teams, you instantly, when you have like mail groups, you also have file groups or agenda groups or whatever other groups you want to work with. Also, you can access everything through WebDAV. This is Dolphin. Just enter username and passwords, and you'll have access to your files. Actually, that's what I've done with this presentation right now, because my new laptop didn't have a VGA interface, and I of course found out 10 minutes before my presentation. I uploaded my presentation into Kolab, and the guy sitting over there, you're awesome, let me use his laptop, and I pulled it down through Kolab. So you can also do it manually, and I'm just going to go over this really fast to show you that the slides are actually there. You can copy paste it later. Set up your Ubuntu server, encrypt some file system in which you're going to put your data, install the operating system, update your operating system, install Apache, install SSO as well, and oh yeah, please invest that 10 euros in a real SSL certificate. Don't use a self-signed certificate, because it's really annoying to every time you add a new device have to confirm that it's really not a scam, and also a self-signed certificate is a lot worse when it comes to preventing man-in-the-middle attacks and everything, because your file system, your browser will not recognize. You have a question?
Or we can go to Let's Encrypt seminar later.
Yeah, that's true.
Absolutely true. Let's Encrypt is awesome. You also have Start SSL, which that's back online again. So you can also have a really cheap SSL certificate. But well, check the firewall rules. And this is something that, much to my surprise, a lot of people actually tend to forget, because they install a bunch of software and yeah, it works, now run away. No, lock down the rest. Install Kolab, add the repositories, add a GPG key, install the software. Oh yeah, and the one command that's really the most important is the setup Kolab command that will run you through the installation of the LDAP server and the generation of the basic configuration. Reboot the machine, and then you have Kolab. Don't also forget to add your SSL certificates to your IMAP server, because if you're only running it on your Apache server, then that's only half of the story. Add users to Kolab, and yay, you've got a server. And yeah, and then close the firewall ports that you don't need. And then you're ready. So, I think I've managed to put it off in time. Any questions right now?
So let's first thank the speaker.
Thank you for coming. Yes.
So I have one remark and two questions first. So the remark, you said you had to open up the network for Calda to have access to its own packet or something. And why don't you just connect to a Unix socket or something? And the same with a MySQL database, you had to set up a root passport at some point and just connect to a Unix socket. Unix domain socket, you don't have a file anymore. But anyway, so that's just a remark. And then my question was, you said you store stuff directly on the IMAP server. Are you using the metadata extension for that, or another one?
The question is, do you need a metadata extension on your IMAP server?
Yeah.
Yes, you do.
Okay.
But Cyrus enables it by default, and Dovecot also has it.
Yeah.
Unfortunately, Dovecot has been encapsulated in a non-free platform recently, so I would recommend looking at Cyrus.
Okay, well, and my last question was, so you said it's very easy to have flat files as in your storage background, but in my experience, that, I mean, if you mean media, that doesn't really scale. I mean, if you have like a mailbox with millions of messages, for instance, then you would have a big syscall, and this doesn't scale unless you have terribly fast I/O or something. This can be slow.
The question is, how can MailDeer scale? Well, we have users with 100,000 user accounts and terabytes of data running on Cyrus.
But
as well.
I mean, this is not the problem. The problem is how many messages you have per directory. I mean, that's the I mean, the total number of files matter. It matters the number of files you have per directory.
Yeah, that's true. And the remark is that the amount of users doesn't matter, but
right.
the amount of files matter. Yeah, but that's all up to file system. So if you optimize your file system, MailDeer can actually Cyrus itself. I've actually never ran into an issue of the Cyrex indexing not being able to cope with any amount of emails, and I've tested it actually on my own laptop with inserting about 1 million bogus mails into a single directory and indexing it with Cyrus. Cyrus itself has no problem with it. It's purely a file system and I/O perspective, but that's I/O optimizing is really a topic that's a whole different aspect. When you start looking at numbers like that, you should think about distributed file systems, sharding, stuff like that.
Well, or use something as a mailer.
Or use something else, a mailer, yeah, okay, fair enough. But Cyrus isn't mailer only, you can use all different kinds of setup if you want. But please experiment with it, because yes, it does matter. And the first remark also you made was, if you have to access a lot of stuff through web services, or if you have to access MySQL through TCP/IP, why not use sockets? Yeah, sure, why not? Just configure it like that and it will work.
But, I mean, my suggestion was to make it a default, then you would have this problem with proxying.
I like your suggestion and I will take it with the guys who package the invention. So, cool. Anything else?
Well, if there are no further questions, let's thank the speaker again. Before you all leave, piece of information, these signs are